So far, we've looked at these graphs and sort of qualitatively looked at and seen how stuff was varying and so forth. But you might be interested in getting actual values for these different points. There's a couple different ways you can do that. One of the useful ways is to go back here and say you want to look at the chart options. So you right click again where we get the edit definition, go to chart options, and you'll see in this chart options one of our possibility is to show min and max annotation. And what this is going to do is it's going to show us on the plot the maximum value of whatever it is we're plotting and the minimum value of whatever it is we're plotting. And will show us where that occurs. So the maximum von Mises stress is here it is 32.5 megapascals right at that spot there. The minimum is going to be this 0.185 right there. You can do this for any of your plots that you want to look at. Before I show you how to get more numeric results from SolidWorks analysis, I need to remind you that the finite element method breaks the solid up into finite sized elements, a number of elements. They're not infinitesimal like you would do if you're doing a differential approach like a calculus approach. It's using a finite sized elements. And we're only, for the most part, only going to be able to get results that we want at the corners of those elements. They're called the nodes. So you break apart into multiple elements. The corners of those elements are called nodes, and for the most part, we're only going to be able to get data at the nodes, at particular nodes. So kind of with that in mind, it's helpful to see how this has been broken up so that you can see what points you can actually find the results at. So I'm going to show you how to show that meshing on the plots that you have. Now, I want to change this one. I'm not happy about, what I want to do next, I don't want to look at von Mises. So I'm going to edit this definition. Again, I've done a right click on there in order to get that bring up. And I'm going to change from von Mises to the normal stress sigma x. And now I'm going to go here to the settings tab. Now, chart options, we actually brought this up earlier when you right clicked and said chart options. You can do that too from that menu, or you can do it from here. But I'm going to go to settings here, and in settings we have this option, different options of how to show the plot, but one of them I want to point out here is the boundary options. And right now it's set to model, and what that means is it shows us the outside edges of the model. But what I want to change this to is mesh, and this shows us now the finite element mesh that was used to create the results. Now, I might want to point out that in between here, I've refined the mesh and rerun the analysis just because I wanted to do that for what I want to show you next with a little finer mesh. We'll talk about later on about how to change the mesh and the significance of changing the mesh size. But for right now, I just want you to be aware that there's the mesh. Here's all the elements, and you can see where they meet those corners. That's called a node. Now, the most useful tool for getting quantitative analysis is the probe. So if you right click on the thing you want to find, so right now I'm interested in looking at the stresses in the X direction, and you can right click on that and then select this probe option. Now it will undeform the geometry just because it's easier to work with a probe in the undeformed geometry. So you have different options in here. One is at location. And what this allows you to do is to click on some point. Let's say I'm really interested in the stresses right in here. You click on that point, and it will give you the stress, in this case it's the stress sigma x, or whatever it is you're plotting, at the node that it thinks is closest to where you clicked, that location. Remember, you can't get stresses, or you can't get these results at other points than the nodes. And so if that point is not where you want, if you can't get quite the location you want, you either have to be satisfied with the closest node and say, well, that's close enough, or else you have to set up the mesh in such a way that you have a node at that point. Next time, we'll show you how to do that, but for today, we're just going to say, well, that's close enough to the point I want. So that's one option, is to click at a particular location and get the value of that location. Now, there are other options that might be more useful in different circumstances. One is at the node number. So now you can put in a particular node number. Well, how do you find the node number and so forth? It's kind of complicated, so it's not clear that's easier, but that is a possibility. The most useful tool here probably is this unselected entities. And what this allows you to do is to pick a geometry feature of the model. So for example, you could pick this whole surface here. And if you say update now, it will give you the stresses on all the nodes that are on that feature, and also tell you the location of those nodes, the X, Y, and Z location of those nodes. Now I don't want to do that now. What I want to do is to take not that face, but I'm going to take this line right here. So I want to look the stresses on that line. Again, I'll select that, I'll say update, and now I've got the stresses on that line. So this is how the stresses for all the nodes that are on that line is giving me the stresses. Down here then is a summary. It shows you the sum of all the stresses, adding up all the stresses on the nodes. I'm not sure how that's useful, but anyway, there it is. The average can be very useful. Now you get an average stress on that line. Max, min, also very useful. RMS has to do with how much variation there is. So now you can get these values on these on a particular line, which is kind of useful. You can get a max and min, that might be useful, but even more useful is to use these other features down below here. This one in particular, if you click on this now, you now see how the stress varies on that line. Now this is pretty good, not bad, gives us a quick idea. The only problem with this graph is it is plotting something called parametric distance. So this graph doesn't actually take into account how far apart the nodes are. It's just treating them as if they're evenly spaced. So this parametric distance is always going to be evenly spaced. No, it thinks the nodes are evenly spaced even if they're not. In this case, that's maybe not too bad. It looks like our nodes might be reasonably evenly spaced. But that's not always the case. So this plot is useful for getting a quick idea, but maybe not so good for reporting results. For reporting results, what we're going to want to do is to get rid of this, take this probe on an entity, and then save the data. And now I'm going to save this data into a CSV file, which I can open in Excel. So now I'll save that. It's going to save this data here on an Excel file. So now if I go to Excel, here's my Excel, and I open that file up, let's see if I can find it. So I think that's the one we just did. Yep, you don't need to know that. Open. And here's the file that we just did. And here is the nodes, the value of the stress on those nodes, and the X, Y, and Z locations of those nodes. So now what we can do is use the geometry information and the values we have here to make a plot that shows the variation with respect to, some reasonable quantity. In this case, the location. So do that. Let's see. Go back to our model just a second to verify. Oh yeah, see the Y direction. Yeah, I'd like to plot how this varies with Y. That makes sense. Okay. So we go back to our, here it is. So now what I'll do is I will just copy over this Y location. Remember for Excel, they want plots in the what you want on the horizontal axis first and the vertical axis next. So I'll just fill those in. Get it to work. And now I can create a plot. I'll just insert, we'll do a line plot here, scatter plot. Maybe we'll do this one. And so now we get a plot of the stress versus location versus Y location, where this now has some meaning. It looks like they are fairly uniformly spaced in this case, but that won't always be the case. And if you do this plot in Excel, you'll be able to account for that. And this also has some meaning. This is 0.1 inches from the bottom, where the other parametric distance means it's just like 2/10 of the way from the bottom. A little harder to interpret. So now that you have the probe, you can then get these values. There's a couple of the things you can do with these things. You can capture the image of what you've got and so forth. But that's the probe that is most useful for getting these quantitative values. And you can use the probe on any of your, you want to look at displacements that way. Just double click on that to make that active, go to probe, and now you'll be able to find the displacement at this, well, let's say that this point right here I'm interested in. So there's the displacement at that point.